Welcome everyone. Hello. Another stream, another very exciting conversation. We've got we, there's just special guests every time, and today we have an extra special guest.
Yeah, so we're talking about sustainability, and we have with us uh, someone who knows a lot about sustainability and 3D printing. Um, so we have on here Buzz, who is a co-founder of 3D PrintLife, uh, a store online that sells many sustainable, eco-friendly materials for 3D printing. Um, he has a lot to say about sustainability. We're gonna have cover a lot of topics here, and yeah, I think it'll be a fun conversation.
Yeah, and for before we'll let Buzz get into his background, but if you have any questions about 3D printing materials or how sustainability in plastics, particularly with 3D printing, like any questions about that, feel free to post them in chat. We'll be monitoring YouTube chat this whole stream and just jump in with your questions. We'll read them out. We'll answer them and just get a bit of a discussion going. But I think without further ado, we'll bring Buzz onto the stream. And here he is.
Hey everybody.
Nice to have you on, Buzz. Thanks so much for joining us today.
Yeah, nice to be here. Thanks for inviting me. Welcome to my humble office.
The winter office, as it's
Yeah, the
come to
winter
be known.
office in the 200-year-old place in Portsmouth.
It's
Yeah,
nice and cozy.
Why don't you give a bit of background and introduction to 3D Print Life, and then we can just dive right into the sustainability
yeah,
topics.
yeah, absolutely. I mean, we started out as a reseller, selling 3D printers, and we were bringing in filaments from other manufacturers. And then we started getting into our own branded filaments, starting with an ABS that featured a bioadditive component that actually promoted biodegradation in the waste stream. Really, we have this bioadditive that is just a food source for bacteria once it gets into the waste stream, and it's designed to work with certain petroleum-based plastics that are amorphous, like ABS, PETG. It'll end up working with polypropylenes and ASAs, which we're going to start doing at some point soon. And slowly over time, our whole product line has evolved with some Frankenstein blends of pure bioplastics that have different properties, and we try to mimic nylon or ABS or PETG with plastics that are in the compostable range. So the way we look at PLA, these function the same way in terms of biodegradability, but they might have the added benefit of being more pliable, more rigid, less brittle, depending on the formulation. We've got a semi-flexible, biodegradable material, and that's really sort of the core of what we're doing on our side, our own filament lines. And then we do carry filaments from other manufacturers like Filamentive out of the UK. It has a whole line of recycled filaments that we absolutely love. Form Futura out of Europe. They've also got some green materials and packaging and some recycled materials. But we also have some standard, more like ABS, ASA. We carry Peak and Ultim and some carbon fiber filaments. So while our mission is definitely to be green, we do still carry other materials just to have that wider range, because people still do ask for it.
So you guys, you carry other brands, but then you also work directly with the filament, like on your own filament line to create these sustainable or I guess
Exactly, yeah. And
biocompatible plastics.
that's really it is certainly the core of who we are. And I'd like to think of us as maybe sort of a curated collection of a few other brands of filaments. And we do carry some new 3D printers, and of course, some pretty exciting accessories that are designed to optimize 3D print, such as the Quinn line.
Yeah,
Oh,
so we're the most recent addition to your store, it seems.
The most, yes, as of yesterday.
yeah,
Really excited
as of
actually to get
yesterday.
it on board.
Yeah, it's been super exciting and it's nice to or it's exciting to have a US distributor and actually like somebody who is super closely aligned with us in terms of the importance of sustainability in 3D printing and in manufacturing in general. So it's been very exciting working with you, and I think this stream is going to be a perfect opportunity for all the viewers to ask questions and learn about how 3D printing can be used with a combination of printing systems and printing materials to really optimize and make manufacturing of certain products more sustainable. Because
Yeah, absolutely.
let's face it, plastic's not very good for the environment. So how are we going to fix
No.
So
that?
good. Yeah.
Right. And listen, I mean, it's one of those things where, look, we certainly are green centric and we focus on being as sustainable as we can, whether it's the packaging of the spooling, et cetera. But we also recognize we live in a world where, we drive we drive cars that use gas. Yeah, even if you use an electric car, it's not my line, but I love it. It's like electricity doesn't come from magic. So it's got to come from somewhere. We're all using something that is contributing to climate change in one way or the other, but what can we do to mitigate that? And in 3D print initially, I mean, when I first got in, I probably had 5 failed prints for every successful one.
Yeah.
And right, so a lot of wasted material, but there's a lot more that goes into being sustainable than just the material side. And I think the Quinley touches on a lot of that. There's a lot of factors that have to do with efficiency and eliminating failed prints, et cetera, and even printing at lower temperatures. All these things are factors that contribute positively or negatively to the environment, depending on how they're functioning.
I think this is like a bit of a theory I have, but I think part of why 3D printing is so wasteful is that it's only it's mostly used as a prototyping tool. So you'll have 5 or 10 failed prototypes before you get the part that you want. But if you extend it then into manufacturing and use and keep making that good part and make tens of thousands or hundreds of thousands of them, then your waste ends up being far, far lower, because your success rate with that good optimized G code you've created is far higher than like when we do production, we tend to see success rates of 80 or 90%. And Eric Woolridge in the University of Kentucky, he did an experiment where they trained people who had never used 3D printing, but they all had them on the same platform, and they went through the same calibration. They prepared G code for them that they knew was good, and I think he was saying they had over an 80% part success rate with completely people who had only been trained an hour before. So
yeah, and I think actually they got quite higher if they took out one outlier.
Yeah,
it was like 90, 94, 95, something like that.
There was just one printer that was misbehaving, but
there's one misbehaving printer out of
Well,
20.
I know Eric is a bright guy, so he's really good at getting everyone trained up in a hurry. I'll say that. But listen, I mean, hey, we're 10 minutes in, and you brought up a great point that I hadn't really considered recently, and that is that you're right. A lot of what's happening in 3D print, in FDM especially, is prototyping, which is just, I mean, it's useful, and it's, you're reducing some other type of subtractive manufacturing or traditional fabrication in the process. So you are being more efficient, but there's inherent waste with that. And one of the things that Quinley does, it's been, I mean, for years, we've talked to customers that, there's so many people that are enthusiasts and early adopters that we've spoken with over the years, want to buy a new printer or get into 3D print for the first time because they have an idea, and they're, it's really opened up this world of, at-home inventors, really, who can create anything. And, it's funny because some people sort of poo-poo that, oh, this guy working out of his garage, or, this girl that took a STEM class is going to try to invent something, and some people laugh it off. I love that stuff. I mean, everything that we're using today, everything we've ever used, initially came out of somebody's invention, right? It was initially in somebody's head. So I love this, the idea of converting your ideas to reality. but so many people wanted to go way beyond prototyping. They wanted to start their own business and use their 3D printer at home to, to fabricate and manufacture end use parts. And really has not been feasible without doing a massive print farm. But something like the Quinley really does change that.
Yeah, I mean, we have like dozens of examples of people literally doing just that. Like in their garage, they have a couple Quinleys set up, and they're making parts at a rate of, between 10 and 75,000 parts per year, which is like full scale manufacturing volumes.
Yeah,
Yeah,
just for like a niche that you might never have heard of, people will start like small and then grow slowly bigger,
Hmm.
and they can do that because the automation isn't just like you can either be small or you can be extremely massive. You can have these steps in between that
Yeah,
lets you scale up.
you can buy one printer at a time as you need it.
Yeah. So I love seeing the growth of yeah, some of the people in our community.
Hmm. Um,
yeah. Well, it definitely takes scalability really to a whole new level. When you start out with an Ender 3 and end up
yeah,
with a manufacturing platform.
yeah, the
Mhm.
fact that you can, spend $1,500 and be able to get the same output as you would contracting manufacture overseas is pretty crazy.
Mhm.
Um,
Yeah,
and I think one of the big questions and the reason we wanted to have you on was because of your background in filaments, because like you said at the beginning, workflow is half of the problem for sustainability. You want to make sure your process is very efficient, but you also want to make sure that your inputs and outputs are actually sustainable. And what happens to your parts over time? Like, how do they get disposed of?
Mhm.
Where does the material for your parts actually come from? Is that coming from a sustainable place? And you guys stock so many of these really innovative 3D printing materials that I think it'd be good to dive into that side of things on the input side of things, because our good filament and good automated work process just it multiplies against itself to in terms of sustainability. So
Yeah, well, if you're
right. No,
producing a
you're
lot, you
right.
might as well produce a lot of something that's green or sustainable
yeah,
rather than a lot
exactly.
of something that, will stay in the environment for like thousands of years.
And you have control over your manufacturing process, so you personally can make those decisions rather than having to, pick from a menu of options that a outsourcer or contractor gives you.
Right, yeah. Well, that's a good point. Like when you're coming up with maybe your own product to sell, you can choose to use an eco-friendly material. You can choose to use eco-friendly packaging, um, and all of these things you can have control, and that can actually be part of your like identity or your brand eventually.
Yeah, agreed. And for me, for a long time, I think, the downside of using PLA was that it was just, brittle and it's not going to last long. The shelf life isn't good. It's really sensitive to moisture. And, we've really been, I mean, to be fair, I mean, we have been lucky with some of our sort of Frankenstein combinations that we've come up with on some bioplastic blends that offer, higher impact strength or pliability, et cetera, but also offer a lot longer shelf life than a standard PLA would. And, you know, while you can create some parts that would certainly last a lot longer, and they'll last on your countertop, forever. I mean, when you're talking about a PET-G with a bioadditive component, it's designed to degrade once it gets into the waste stream. So that
Hmm.
high bacteria content. It's not going to degrade on your desktop or in your end use part. So you still have something that can be functional. And then when it does reach end of life, once it hits the waste stream or, certainly support material, et cetera, hits the waste stream, then at least it is greener going out.
Hmm.
Um, and you brought up a good point too about, just being sort of in control of your own production. We're able to control the materials we use, the colorants we source, um, and we're not sort of selecting things off a menu from a third-party manufacturer where we say, oh, one of those and one of those. We have control over where we're sourcing not just the PLA or the PHA, but where is that coming from? There's lots of different available sources. Is it coming from China? Is it coming from the US? And that has presented some challenges for us in terms of compounding and availability, especially this year with supply chain. It's been a challenge for sure. But we've been lucky, and we've got some European brands that, even though they originated out of Europe, we're now manufacturing them here in the United States.
Hmm.
And the ones that we aren't, we're converting to that as well. So we're, sort of eliminating that travel from Europe to here to reduce the carbon footprint.
That's pretty
That
big.
side, it's a lot. I mean, we're never going to sort of turn something down because of where it comes from. If it's a viable material and it sort of adds to the overall depth of our offering, but it's also a high quality premium blend that we want to adopt, but we still want to try to find a way to make it here whenever possible.
Hmm.
And I mean, that's pretty cool. The fact that you can get all your materials from North America, or some of your materials from North America, um, produce them in-house and sell within your country or even within your state. It's pretty great in terms of, because like shipping is one of the largest contributors to GHGs, and a lot of people, the first thing that comes to mind is, oh, because you're shipping by plane, right? But there's actually so much more that goes into shipping waste and shipping's um, impact on the environment. There's not just the moving the packages themselves and the fuel spent doing that, but there has to be shipping facilities and shipping infrastructure that may not be used at 100% capacity, or like you have all of this infrastructure, these roads, these warehouses built, these people who have to work in the warehouses, that have to drive to the warehouses. There's all of this like extraneous thing that contributes to shipping waste, and then the more inefficient a route your package takes, it's not only that you're spending more fuel getting from point A to point B, but then you're also, the package is spending more time in all of these warehouses, taking up more space in all of these warehouses, doing all of these changeovers, and it just ends up being really, really wasteful. There's always that example that I like to fall back to of one of our FedEx shipments. We had ordered it was for Ender 3s coming from Shenzhen in China. And so the shipping route it took, so it's in Shenzhen, we're in Vancouver, Canada, and it's only supposed to go across the Pacific once, you would think. But it turns out the route it took was went down to sorting facility in Hong Kong, Japan, then it went to Alaska, which is getting closer. But then for some reason it decides, well, it needs to get sorted more. So it goes back to South Korea, back across the Pacific, away from Vancouver. And then it takes this really long jump from South Korea to somewhere, I think in Tennessee, there's like a big shipping hub that
There is a
FedEx
big
has.
hub there. Yeah.
Wow.
And then it goes back across the US to Seattle, and then finally to Vancouver. So it does all of these like random jumps, and it ended up traveling like 3.5 times the actual distance that was required. And that should be a pretty big indicator that, like, if that is how our shipping infrastructure has to operate in order to move goods overseas, there's something fundamentally wasteful and incorrect about how we are moving products around the world.
Yeah, well, that just can't be right. I mean,
Yeah,
3 times farther than it needs to
like
be.
how is that? Because presumably it's a company that wants to minimize their costs. How is that the most optimal way for packages to go? And that's
Yeah.
not in an exclusive case. Like you'll always see things getting routed really long distances to hubs, because that's, with the system we have now, that's the most optimal way.
Even though it's
Yeah,
not
well, I've
really.
got no pushback for you. That is brutal.
Yeah.
And we see it too. We ship packages every day, and I cringe sometimes when so many, first adopters are just trying one spool first, and of course, I get it.
Yeah.
But just the amount of fuel and expense that goes along with that is really frustrating. So we're and we're certainly not the first to do this, but we're starting to now we used to do it, and we're reintroducing 100-gram sample coils. We could do 50. We decided to go with 100, so you can actually print a full bed sheet to get a good gauge on the filament testing. But these 100-gram coils that you can put in a little mailer bag, it's a lot easier to ship for people to test out. And hopefully, then when they come back and decide to order a spool, it'll be 2 or 5 at a time instead of that first initial order. It's always, oh,
Yeah, well, we try to order in bulk when we can. Like we might start with like a couple rolls just to test it out, but um, there's huge efficiency gains to be had if you buy a lot of one material and you just use that for a while because you don't need to change your G code after because it's the same material. Um,
right.
yeah, so like keeping your material stock like maybe down to a few different colors or a few different brands, we find that really helps sort of reduce well like waste because you don't have to iterate when you get new filament. But also it just saves you a lot of time. Um, and in that case, you're being sustainable with your own time, which is uh, really valuable. You don't have a lot of it, so
Yeah, obviously it helps eliminate jams and so forth as well when you're switching back and forth between different temp materials and different levels of abrasiveness, etc.
Hmm.
Um, I got to say, I was really impressed with another aspect to this that we're sort of really proud of is that on some of our bioplastic blends like Dura and Omni, the print temperatures are below 200 C, as low as 175 C. So you're using less energy at that point. You don't require a heated bed, so that helps as well. But I was really shocked when you tested yoga because you're trying to get as low as you can on the extrusion temp, and you were able to. What was it? 130 you got down to?
yeah. So I'm holding up an octopus right here, printed in the Yoga
It's a
Flex.
flexible.
Yeah, and it's a flexible octopus. It's pretty cool, this material. It's like slightly more rigid than your average TPU, but it's still very flexible.
I like the finish on it a lot too. It's actually a glossy.
Yeah, and it's this was printed at 135 degrees Celsius on a normal hot end. Like 135, like my bed can get to that temperature.
Yeah.
And it was on an unheated bed, so the amount of energy used for this part would be like a lot less than the energy used for a part in typical PLA or nylon or PETG or something.
Eric's actually got I don't know if it's been published yet, but he sent us Eric Woolridge from SCC in Kentucky sent us this report about the well it was in regards to emissions, but it did have energy use of 3D printing and of injection molding, and it turns
Mhm.
out 3D printing can be much lower,
Yeah.
um, which is pretty interesting. And it means like the more manufacturing you can offload onto 3D printing, the uh, the more you actually save on the manufacturing side, whether it's because you're heating a much smaller element or the plastic the plastic itself doesn't have to remain very hot for very long.
Hmm.
Um, you can actually save a lot of energy for your part. I'm just waiting for the day where you get an extruder that doesn't use a heater and just relies on friction and compression to melt the filament.
That would be pretty cool.
Yeah.
Well, I mean, pellet extruders use a
Yeah.
combination of heat and friction, so they're
Yeah.
getting there.
Soon.
That's
Yeah,
interesting. So an
and
interesting part about the like the energy use is that actually print time is also quite important. So if you can reduce the print time, then your bed is spending less time at temperature. Um,
yeah,
so if
well,
you can
it's funny
improve
you
your
bring up a good
efficiency, you
point
get less
about
energy.
pellets and using trying to use lower temperatures or whatever, but even using 175 versus 285 filament, uh, the energy, the torque required on 285 for the stepper motors is 3 times that of what it is on 175. So there's all these little, tiny little elements that come into play.
That's interesting.
Yeah, well, like little efficiency gains on one printer is not a huge deal, but when you're trying to mass produce stuff, if this stuff multiplies across a print farm for every part that you print, then small gains in efficiency means you're paying like 20% less on electricity bill, and that starts to add up.
Yeah, and
Right.
I think a lot of people aren't talking about it because 3D printing really hasn't been looked at through the lens of such high volumes. At least FDM hasn't.
Hmm.
And so not a lot of machines are built with that consideration in mind.
No,
And
I mean, turn on a couple light bulbs, it's the same as a 3D printer, really. Like,
yeah,
they're not that energy intensive, but um, once you have a
Yeah,
bunch of them,
the cumulative effect is
yeah,
real.
yeah.
And I mean, at this point, we've got to have, between 500,000 and 750,000 FTM printers out in the space right now
There's
in the
actually
US.
the number is, oh, in the US, the number globally is 4.2 million right now as of this year,
Yeah.
which is a
Now, is
lot.
that just FTM or does that
That's
include,
FDM.
okay.
Yeah, it's a lot of printers.
you're gonna be in a lot more in the future too,
Yeah.
as
They
Mateo knows.
estimated at least all the market reports I've been looking at, they estimate 100 million by 2030. So 20 times today. And there's some interesting, maybe we can talk about that later, but there's some interesting insights I gleaned doing like some calculations on how much that would actually cost to operate if it was unautomated versus automated. Um, but I think we can talk about that later. I want to keep talking about
Yeah,
the sustainability in the materials. So something interesting you mentioned that I think everyone would be curious to know, and myself included, is how do these bioadditives actually work? When you put them in a filament, what does it do to make the filament more friendly downstream once it goes into our waste stream?
So great, yeah, great question. It's a biocomponent that is, first it's got to be compounded with a carrier resin that will be able to bond with whatever plastic we're looking to pair it with on the filament side. So it really doesn't work well with semi-crystalline materials like PLA, and there are some use cases for that, even though it's a compostable material on its own.
Mm-hmm.
But essentially, the short version of what it is, it just that biocomponent provides a food source for bacteria in the waste stream. So when that part gets into a commercial compost or an active landfill facility, and just to give you a little background, commercial compost is, gets thrown around a lot for, especially for PLA. There's maybe in the US between 2 and 300 commercial compost operation, whereas an active landfill facility is more of an anaerobic facility. But think about a capped and tuned landfill, and then think about, essentially what they do is they have this high leachate bacteria content, 40% leachate bacteria inside of this sealed landfill environment. And that bacteria consumes the material in the landfill, and it produces landfill gases like CO2 and methane. Now, the methane is captured and refined and then burned to create electricity within a short amount of time. So there's this, hence the landfill to energy facility moniker. Now, there's about 4,500 of those in the US. So there's a much greater chance that your material is going to end up in there than in a commercial compost.
Mm-hmm.
So, but in that environment, that bacteria is looking for a food source, and the biocomponent to our material is really just that. So, to break it down really quickly, we initially tested ABS with our bioadditive component. At the time, back in 2015, ABS was one of the primary use materials. So it was a good market separator for us, and it was just a good win for the environment in general.
Mm-hmm.
But we printed some bracelets and ran some ASTM testing. And what happens inside the vat when you're doing these tests? The bacteria, comes to a material and it tries to consume it. It's almost like it's looking for a food source. If you think about it like a great white shark trying to take a bite out of a boat, it's, in some ways, it's looking to see if it's food or not. And bacteria acts the same way. In the vats, what happens is with the standard ABS parts, uh, what you're looking for in these test results are CO2 production, because that tells you that the bacteria is converting that plastic into CO2, meaning it's being consumed. When you look at the ABS parts that were tested, you do see a spike in CO2, and then it drops off after, in a 45-day test, after a 2 to 3 weeks, that CO2 production in the ABS vat drops off a cliff. And it's not that they're consuming ABS. When the bacteria comes to that ABS part and starts consuming it, the bacteria actually releases an electrical charge, which
Hmm.
essentially is like ringing the dinner bell for all the other bacteria in the vat. So they swarm over and they try to consume the ABS part. They can't, so they end up cannibalizing each other. And that's where you see the CO2 production in that vat. With our bracelets that had a bioadditive component, in this case in our Enviro ABS, it functions the same way in our BioPG, that CO2 production remained steady throughout the entire length of the test. So just showed that they were actually consuming the PEG along with the BioComponent, because as it's being extruded, it's blending, into the material really well. Luckily, you're not losing any material characteristics of the base material, so your eco-friendly ABS and PEG still print the same, they still function the same, your end-use parts have the same mechanical properties, so you're not really losing anything there. You're just gaining that extra sort of biodegradability once it gets into the waste stream. Now, when we extrapolate the data on how long it would have taken both vats to degrade, and I think you do 3 vats per material just for control, but the ABS parts would have taken 800 to 1,000 years to degrade, whereas with our Enviro ABS with the BioComponent, it would have taken 12.7 years.
Right.
So while it's not, look, it's not like a PLA where a commercial compost it's going to degrade by 60% in 180 days, but it's a vast improvement
Yeah.
over, that 800 to 1,000 year range.
And it's
And
it's well within the lifespan of a landfill too,
Yeah.
yeah, and a human being.
and a human being. Yeah, that's important too.
Yeah. So like when you
Yeah,
throw away your ABS, your bio ABS 3D print, um, it'll spend some time in the landfill, and then I'm assuming like between the time where you throw it away and it's completely decomposed, it will actually have produced some amount of gas that's then turned into energy, at least if it was
yeah,
used at the right facility.
yeah, that's the process. Yeah, and unfortunately, we're all sort of at the mercy of our local municipality when it comes to where our trash ends up.
Hmm.
Hmm.
Unless you go out of your way to do some research and find where the commercial compost is, or what kind of landfill your trash is ending up in. It's again, we're all sort of, once it's out of our hands, it's out of our control, unless
Yeah.
we really actively pursue where it's going. But certainly, if and when it ends up in that environment, look, with 4,500 active landfills in the U.S., there's a better chance it's going to end up there than not.
Hmm. Yeah. Coming from Canada, we're well acquainted with that issue. Like there's a few years ago, there's a point where our government was told that we cannot no longer ship garbage
Hmm.
out of the country or recycling, because it was actually there's a really good investigative report done by the CBC, which is our public broadcasting station, and they had gone and followed, like, okay, what actually happens to our recycling,
Hmm.
and they found out it was getting burned. It was getting shipped off to I think it was Malaysia, and they were just
Yeah.
it was just being burned, and that was happening with most of the things thrown into the recycling here. So the fact that you
It's
can,
brutal.
I know, but
Like we do all this work to recycle and sort and stuff, and it just
yeah,
gets burned.
it
Like,
is it
damn.
is kind of a, and this is where I think, going back to that idea of being able to choose your materials, I think that's really where the sustainable filaments can come into play, because it shouldn't be, and this might be slightly controversial, but I believe it shouldn't be up to the consumer to deal with um, this this waste that in the products that they buy. Who's responsible for deciding, like the people responsible for deciding what a product is made out of is the producer, is the company, and it shouldn't be left up to consumers to deal with um, bad or environmentally unfriendly decisions that these producers make. So in the case of sustainable filaments, where you are the one doing the producing, and now with Quinley you can actually do manufacturing, you have this option to take control and make decisions at the point of production to use more environmentally friendly materials and not concern your customers with having to invest money and time into dealing with sorting or dealing with all of these downstream solutions, because ultimately it should be the responsibility of the person that's making the product.
That is it's an excellent point, and it reminds me of years ago, in the music industry, people would complain about, sort of the pablum of artists that all sound the same coming out. And there was some famous, quote from a record executive that said, the public wants what the public gets. And we are sort of at the mercy of, as consumers of whatever the producers are putting out. Those are our choices, unless we're making something at home ourselves or doing our own fabrication. So yeah, that's a really excellent point. And I think on our side, like, we look at it as, if you think back in the day when, it was like 80s and 90s when dolphin safe tuna first started appearing on the shelves. I don't know if that rings a bell for you guys, but people would eat tuna in cans all the time, and then it was, there were all these sort of news reports coming out about dolphin meat being included in that tuna, and people started freaking out because they didn't want to eat dolphins, because we know they're intelligent, sentient beings. So companies started changing the way they were sourcing their fish, and you would get, dolphin safe tuna on the label, and people would have that choice. And if it was like, all things being equal or close to it, if you're paying a little bit more for the dolphin safe, you're going to go for that every time, right? So, we do have that power as consumers to change things by demanding that things be, greener, et cetera. And I think, to be fair, as a society in general, I think we've done a great job of that. I think everyone at this point is aware that a lot of consumers and companies are really interested in improving sustainability across the board. And there's always going to be some people on the fringe that think it's hoax or whatever, but climate change has affected our business over the past year. We had the beetle in Canada that has helped cause a lumber shortage, and there's more months during the year when that beetle's able to be active because winters are shorter. We had a compounding plant last year taken out by a hurricane. It was a really powerful hurricane, so you can't argue that climate change isn't real when you see these category 4 or 5 hurricanes occurring almost every year or two versus every 30 to 40 years, or whatever the old sort of occurrence was.
Yeah.
So yeah, I know I drifted there a little bit, but you really bring up a really great point. I think as consumers, we do at least have that ability to raise our voices and choose with our wallets what it is we're bringing into our homes to use. But yeah, like on the waste stream, we are at the mercy of what's out there.
It's hard to make change, and I think it's a little bit, it depends how it was deployed, but I would honestly say it's a bit irresponsible, because people think that's the only option that they can do to help, and a lot of people get focused on, or have been focused onto, these very, very narrow avenues which are ultimately out of their control. And so yeah, the fact that we do have more say now, and can vote with the types of products we have, and have manufacturing technologies that allow more sustainable materials to be in the market is very interesting. And I think it's a good transition. Steph's been asking, like, we should actually talk about some examples of the sustainable materials you guys sell, and we have some pictures I'll pull up while we talk about it.
Browse their site, because they have
Oh yeah, why don't we do that?
Yeah. So you guys, it's not just materials that are using the bio-infused plastics. You guys also sell like recycled PLA, for example. Why don't you tell us about that?
And a great point. So our bioadditive component is really only featured in our Enviro ABS, our BioPen G material. We are going to be introducing it into some other materials the coming months and years, but we're not there yet. But So Replay or recycled PLA is we're really excited about this. We just launched it. God, it was probably 2, 3 months ago now, and you know, this year's been a blur, so it could have been 6 months ago.
Yeah,
It was just a
fair.
few months ago here at this point. So this is a 100% recycled PLA. We have used a little bit of bioplastic to just stabilize it a little bit, and we've added some black color because when you're using upcycled PLA scrap, you've got all the colors of the rainbow involved, and it can get pretty gnarly looking color lines. So we just added some colorant to deepen the color spectrum a little bit. There's still going to be some variance as we go through this product line, always, but it'll be in that sort of really, really dark black, like Batman's favorite color, if you think of it that way. But for years, customers have offered to send us their waste material. So, you know, the rafts and failed prints, and they've wanted us to take it and recycle it and convert it to filament. And we've always wanted to do it, but there's a lot of challenges with that. And we really can't accept sort of third-party waste material back into the shop and then try to convert it into filament. Because as you mentioned before, you know, having control over your manufacturing is key. And in this case, we'd have no control over that sourcing. So we could get a bin of material that they're telling us is PLA, and it may very well be, but if someone accidentally puts some PETG or ABS or HIPS into that bin, then we've got sort of this hodgepodge of different materials that process very differently at different temperature rates, et cetera. And when we try to extrude that, you're going to end up with material that either just won't extrude well and we can't get it to a tight spec in the 175 or whatever diameter or modality we're targeting, or it'll just print here. So you've got a lot of factors to consider there. So we've always had to sort of turn people away. And I applaud places that are really trying to still go for that, try to take that, customer waste and convert it into filament. I mean, the Filabot's a great example of how you can try to do it at home, but I mean, extrusion is not, it's not easy. And when you're dealing with multiple materials, it gets really complicated. Every time you run a material through a screw, you're degrading that polymer.
Yeah.
So you are altering it a little bit. With our reprint line, we've been lucky enough to just take all the scrap that we have from our PLA production. So every time you run a spool of filament or a production run, and you're going from one color to the next, there's bleed through, and when you're changing from 175 to 285, there's just inherent waste in the process. So the replay line is made entirely from all of that production scrap. So we have full control over the sourcing. We know what it is, where it comes from. We know what material it is, what grade of PLA it is, and that's a factor too. Like, just because it's PLA doesn't mean it's PLA. There's, if it's PLA from China or elsewhere, there's fillers that might be even in the U.S. I mean, we use impact modifiers that aren't PLA, although it's a bio-based plastic component, not not something else. But you still don't know what you're getting depending on what you're using from third-party material. There's lots of different grades of PLAs out there, so they're going to function slightly differently. And we don't want to ever put out anything that is inconsistent. We really want people to be able to put one of our spools on their printer and have it be consistent from the beginning of that spool to the end, and then from one spool to the next, from color to the next, one production run to the next. So we're constantly trying to keep that tight spec. And it is a challenge. I mean, every filament manufacturer has issues in production from time to time. It's just about putting out the most consistent material you can. And so we're really excited about having a recycled PLA now. Love it. And look, the guys from Filaments have been putting out recycled material for a while as well. Now, their sort of featured recycled PLA, their RPLA, uses less recycled content, so they're able to do multiple colors. So the Filaments of RPLA has all these different colors, and you might say, well, why is yours only black? And that's really why. But they have a lot of materials using various percentages of recycled content, achieve some really cool colors along with a good quality material as well. So, but on our side, so we've got this recycled PLA. We love this material. The feedback has been really positive so far. I know we got a spool on its way to you guys. I can't wait to see what you think about it.
Yeah.
And how it functions on the Quinn.
Actually,
We have another material. Oh, go ahead.
we should talk about that because we're planning on testing it to use with our packaging because right now we have these plastic, they're just regular PLA packaging inserts um, for a Prusa, and we've done it on our Ender as well. Um, and if we can use, because this is ultimately a disposable component, and so if we can
Mm-hmm.
use something that's either bio-based, so it does better downstream, or this recycled PLA, at least we're not throwing out, energy intensive, high quality material. We're
Mm-hmm.
actually able to improve sustainability a bit by choosing greener materials. And actually, Jack had a really interesting question with the recycled PLA. How does it work with PLAs that have things like sparkles in it? Can sparkly PLA even be recycled, or
Hmm.
like other kinds of additives?
That is a good question. So we have a sparkly PLA. The Form Galaxy has a lot of aluminum flakes in it. I really don't think that would be, if you were just sort of recycling that material by itself and rerunning it through a line, it's the color is going to be the issue there. If you're able to
Mm-hmm.
recycle each individual color, um, great. When you mix it all together, I don't know how that's going to end up looking. You
Yeah.
might have to color it with some black. But I don't think it would affect it that much. It's really not. The aluminum flakes are, just that, and they're not really altering the plastic, so to
Mm-hmm.
speak.
That's fair. Yeah, I mean, it would be. Yeah, I'm really looking forward to getting our hands on the replay because not only like not only is it recycled, but as Kevin mentioned, it's like the price is really good. You wouldn't expect, you would think that it's a more intensive processor or something, and it'd be more expensive because that's often the compromise that you have to make when choosing more sustainable materials, but it really isn't in this case. And while you were talking, I was searching the store for other recycled materials that you stock, and they're all like very reasonable prices. They're actually within the price range that the normal material would be, which is I
Yeah,
think excellent.
we're we're lucky there. So our Pro PLA, which is what the replay is based off of, is a virgin PLA with an impact modifier, which is a bioplastic.
So it comes
Colors,
it
but
comes from this from waste uh when making this Pro PLA.
exactly,
Okay,
exactly.
got it.
So part of the reason why it's there is some labor involved in collecting all of that scrap and grinding it up into pellets, relatively uniform, and then going ahead with your production run, which is why it's all 175, just it's easier to stabilize at that
Hmm.
diameter. So at least the raw material sourcing isn't X number of dollars per pound. It's we've already paid for that material. We already have it. It's
Hmm.
just now scrap. So there's a little bit of labor involved, and you want to make sure it's clean, um, and it doesn't have any contamination to it. So you just have to be careful in your production how you treat it. But yeah, so we're lucky to be able to offer it at that price. I mean, we'd love to be able to charge more for it, but it just seems like the sweet spot for that material for me.
Yeah.
I like how like a lot of the recycled material on your website comes in these cardboard spools. I'm seeing this a bit more often now, either the option of a cardboard spool or even reusable spools where they kind of spin apart and then you can add your own material onto that.
Yeah, the master spool option, which I love
Yeah.
too. It didn't take off as much as I had kind of hoped. That master spooling option, which it is really difficult to produce the filament coils that are just sort of the fills for those.
Right, makes
That
sense.
takes a heavy skill set at the extrusion house level, but but those spools I really do dig. You have to waste some material to print it, but you're using the same spool over and over again. With ours with the cardboard, We've had struggles with cardboard shortages this year, so we've had some gaps in production because we're waiting on spooling to come in. That's been a challenge for us. But I still prefer overall to go cardboard. Plastic is easier to recycle, and it's easier to recycle than cardboard.
Yeah.
But but cardboard's biodegradable.
Hmm.
So, there's that aspect to it where you could just throw it in the trash and you're fine, right? Or you could throw it in your backyard compost. Now, our spooling currently uses a metal end cap to secure the spooling in place, whereas the European model uses a glued cardboard spool. We're actually trying to transition to that glued version, but I've had again some delays this year because of COVID and cardboard shortages, but that's what we're going to end up migrating to, just to make it a little easier in the waste stream for us on the schooling. But I mean, we've been doing that since 2015. We first put our first enviro line out, eco spooling, and there's been since then just a ton more manufacturers going that route, which I love. I think it's great.
I think doesn't Form Futura for their smaller spools, they do the paper and glue route, I think.
Yeah, they have like the internal tube
They
is like
do.
a cardboard tube.
Yeah. Yeah.
Yep, they do.
It's
They do. And Filamentive has the same version. In Europe, they were able to source it that way
I see.
a few years ago. And we're trying to replicate that here in the States.
I wonder, yeah, that's interesting. They must have a source closer to them, because one of the things that we wouldn't want to see is having to ship stuff halfway across the world in order to
Right. And that's why
Yeah,
we're
that's
not
that's
bringing in
cool.
spools from Europe to do that
yeah,
process. We're trying to
which
source
is
it all here. In the meantime, we're still produced on our cardboard spooling.
that's awesome.
And
Yeah.
I mean, I do like our schooling. I wish it was cardboard, but at the same time, it's, far, far less plastic. And that said, I mean, look, a lot of the schools that are out there on the market are made from recycled plastic.
Hmm.
So that's good. But, you know, it certainly does not help to just add more plastic to the environment just for packaging
Yeah.
purposes like that. So
Yeah.
we're really proud that we haven't used plastic spooling ourselves for quite a few years.
That's actually, yeah, I think that's a kind of a it's a lot of people don't realize it's actually, and I think it's only because of economies of scale, but it turns out we've gotten to a point where plastic is both uh, less environmentally damaging to produce and to recycle than paper, which is
Mm.
kind of a ridiculous idea. But then you realize, like, well, the damage it does to the environment, all the stuff that doesn't get recycled, which is 91% of plastic, I think,
Right.
in North America, that's terrible for the environment. And you also realize it is an economies of scale thing where if enough people start switching over to using paper products instead of plastic, eventually the process and the infrastructure for paper is going to get optimized to the point where yes, because fundamentally it's more green than plastic. It's just that we haven't gone to the point. It's like that whole argument for, oh, it'd be too hard to set up renewable energy. We already have coal infrastructure, so
Yeah,
let's keep using, natural gas, or let's keep using coal and oil for everything. We don't have to build anything new, so it won't make any more GHGs.
yeah. Eventually, those savings pay off
Yeah,
in the
yeah.
long run. I've seen a similar thing about using like plastic bags versus paper bags. Like it costs uses a lot more energy to make a paper bag at
But
the
it's
end of the day.
because there's so many fewer paper bags being made. I think,
Yeah, because everyone uses plastic bags
yeah,
at least currently. So,
like it must be orders of magnitude difference.
hmm
Where
Yeah,
if they were
agreed.
all
And
things
that's one
equal,
of those where it's counterintuitive until you dig deeper into the details, and,
yeah,
and that's and that's exactly why. Speaking of just sort of to get back on the recycling thing on filaments for a minute.
sure,
So, we've obviously had to turn away third-party materials that we'd love to be able to recycle to convert into filament, but because we have no control over what exact kind of plastic it is, there's no way to tell when it comes in the shop if something is, I mean, without doing some kind of spectral analysis or specific gravity testing. Like I'm not going to check to see if it's PLA or ABS.
hmm, and you
We're
still
just going to
wouldn't even
reject it.
know really because of how different PLA can be depending on who makes it.
Yeah, and there's different flow rates and melt rates for different grades of PLA. So it's really, it's difficult to keep it consistent if you're going to go that route. But on the flip side, a lot of people like using PETG filament. And PETG is the most recycled and recyclable plastic there is. But but a lot of people assume that their PETG parts can be recycled when they reach end of life with a base product. But the truth is, it'll never be accepted by a recycling center without the recycling logo on it, the number indicating what kind of plastic it is. So, you're never going to be able to recycle it in that way. Now,
What if you could
we
print
are.
on
Oh,
the
go ahead.
logo? That could be interesting.
Does that work?
Yeah, I was just going to say. Oh, sorry. Say again.
Well, what if you could like emboss the logo of the recycling number onto your print? I mean, you'd have to actually make sure that you print it in the right material, but as long as you're keeping track, then do you think the recycling places would take notice?
If they know it's a 3D printed part, they might not. If it's injection molded with some branded packaging information on there, then they're going to accept it. So that'll be up to your local, your local recycling center. My guess would be that it would be rejected if they figure out that it's a 3D printed part. That would be my guess. But we are coming out with, we have our BioPEG, which is it's a virgin PEG with the bioadditive component, so it's degradable in the waste stream. Longer term than PLA, but still degradable in that sense. But our next, one of our next upcoming materials, we have a couple of materials that I'm even hesitant to talk about because I'm not sure when they're coming. But one of them is going to be a recycled, 100% recycled PEG made from recycled drinking bottles with our bioadditive component. So it'll be greener coming in and then also greener going out. So you've got that added component where, hey, like maybe you can't recycle it, but it was recycled initially. And when it gets into the waste stream, plus bioadditive component with it. So that's one material we can't wait to produce. Sourcing that recycled PEG this year has been interesting, but we're close. We're down to a few candidates.
That's awesome.
So we're hoping to put that out here. If we can't do it by end of year, hopefully Q1 will have that out. But another material we're looking to get out by the end of the year is a truly backyard compostable filament. And it's similar to PLA in its printability, but closer to ABS in its mechanical. So I can't say much more than that, other than I'm really excited about it. I can't wait to get it out.
Yeah, we've heard a little bit about it, and the fact that it's backyard compostable is really exciting. I think I've actually seen a photo of it. This has been in the works for a while, right? Like a year or so?
It has been in the works for a while, but I can't.
Yeah, top secret.
But we will have it out as soon as possible.
We'll find out about it soon enough. I feel like I may have seen a photo of this.
Well, we're trying to figure out what the actual final name is going to be on our side. So we'll see what happens.
That's so exciting. Kevin brings up a good point, and you had mentioned master spools a little bit before as a way of reducing waste, because when you think about it, like the spool is 20% of the weight of the filament that you buy, just the spool, and then the packaging is even more than that because it comes in a box, usually comes in a bag, like a heavy bag as well. Do you have any insight why things like master spools never really caught on? I know a lot of brands offer it, but I don't see too many people using it.
Yeah, no, I think the real issue there is being able to source the refills for that. It's getting that plastic coil that you'll put on that master spool and assemble it. That's really where the struggle is. There's not a lot of shops that can manufacture it at high volume.
Okay.
And there's also the fact that a lot of people, you have to print that spool, and depending on your printer, you might need, you need a decent sized print bed to get that printed. That's part of it. I'm not sure. I love the concept. I love everything about it, really. I think it could just be as simple as, you know, you buy a spool of filament, you know, if you know the source and you know you like this brand, you know it's going to work every time. You're just going to drift to that. When it's something that you need to print the spooling yourself and then assemble, if you put that coil on, you don't attach it right. I mean, these spools, when you, I mean, you know how it is when you undo undo a new spool, like it can really like, you know, sort of
Explode.
spiral
Yeah.
on you pretty quickly. So there's a danger of wasting all of that material anyway,
Hmm.
or causing, you know, causing some crossover knots in the material when you're trying to, you know, use that refill coil.
Well, I can see
So
it being maybe for like hobbyists who want to save a couple bucks, because I know you can get these refill spools a little bit cheaper than if you buy them on a spool.
yeah, but it's just, I think it's just, you know, maybe it's an ease of use issue, and also from the
Yeah.
manufacturing
It's probably
side.
just a pain.
Yeah, it is. Oh, it's a real pain. It's really labor intensive.
Yeah,
It's a higher cost to make. So you've got to factor that in as well.
right.
Um, now there is a lot of master spooling that happens sometimes in manufacturing itself. You're, you know, run onto larger spools and then respooling on the
Yeah.
smaller ones.
Yeah.
We prefer direct wind because we're skipping that step, labor and sometimes shipping from one place to another. That drives me insane. I can't deal with that. So
Hmm.
we love direct wind across the board. Um, but um, yeah, I lost my train of thought there. Couldn't
No,
let you hear. Where
that's
did this go?
interesting. It's interesting hearing from the other side because I like the concept too, but I've never used a master spool.
Yeah,
Like
same.
out of the how many kilos of filament have we probably used since last year? Like
500?
5 or 600?
Yeah.
And no, it's I guess yeah, I think ease of use and we're it might be on depending on use case too, because I have a sense that as you get into higher and higher volumes, it would make sense to use that as you kind of consolidate your sources. But for us, we experiment a lot with materials and our products are constantly being updated. We don't know what the best material or source would be for it yet. We have like one supplier that we consistently buy from right now.
Hmm.
And and then of course with COVID, that all just went out the window
Hmm.
basically.
Yeah,
Like there
Yeah.
was no way to consistently source filament or anything really, so we couldn't like stick to one.
yeah, it has been a challenge, and a lot of times, you know, if you want to get the PLA to manufacture it, you know, you better be buying it by the container load,
Yeah.
and not by the Gaylord. You just won't get it. But we've been lucky. I mean, look, we have a lot of Frankenstein blends, so you know, we've been lucky because we have to source, you know, our PHA for our play fab. And actually, I know you guys asked me to go through some of the material lines, and I hate being an infomercial here, but
No, go
um,
ahead.
just to
It's
kind of,
genuinely fascinating.
so our play fab line was actually our second material that we launched under our brand. And it's a PLA PHA blend. We're not the first and only one out there for sure. Our PHA is sourced in the US, as is the PLA,
It's just
and
done.
you know we make it to a
Yeah.
tight spec. But this material is really, it's almost like we call it a tough PLA. It really has some of the pliability of PETG
Okay.
and you know, more impact strength like ABS, and it's far less brittle, and the shelf life on it is outstanding. And Yale University had, you know, uses this pretty much exclusively in their architecture department on their Ultimakers.
Uh-huh.
And I know you guys have ever used an Ultimaker, but you know, something about the PTFE tubes just, you know, eats up PLA and makes it just crack inside of that tube if it's
Yeah.
left in there too long.
Yeah.
And so they had a spool of play fab that had been opened and used, and then someone wanted a different color, so they put it on the shelf. And they figured it would had been sitting there for about 18 months exposed
Huh.
and play fab. And they just decided, oh, what the heck, we'll throw it on and see what happens. And they said it printed perfectly, like it was day one. So the shelf life on it is really extraordinary. And that was really just blind luck. I mean, that was, you know, just a happy accident that worked out for us. Um, but higher lifespan has been some of the benefits of experimenting with some of these other bioplastic blends that we've been doing.
Well, that's actually
And
I just thought of something there. If you don't have to throw your spool into a filament dehydrator for 6 hours, that's a lot of extra energy that you didn't have to spend taking the water out of
yeah,
your filament.
that helps. I mean, PLA, once it's open, degrades at the rate of about 10% a month.
Oh,
And that's pure, just, you
10%
know,
a
sort of
month.
standard PLA. Most of the PLAs out there now have some kind of impact modifier to it to help improve with durability and less sensitivity to moisture and lifespan. Not all of them work as well as others do, uh, but we just got lucky with the plate line. So it's really strong. It's really geometrically accurate. It prints at a higher temp than PLA, sort of in the 230 range is kind of the sweet spot, but it really has a lot of extra strength, those types of characteristics, without having to anneal it, like some of the other high strength PLAs. And then, you mentioned our yoga flags. We love that material. That's another one of these Frankenstein's blends. And it's like, people ask me, what's in it? And I kind of use this line about home-based seasoning. It's like a little bit of this, a little bit of that, and a whole bunch of don't worry about it. Right? And it's all biodegradable material.
You just see you're on the production line, just like throwing in a pinch of something, a pinch of something else.
Right. We just, we take some of these materials, you put them on the line. That's really kind of the fun about 3D print, is that it is kind of the Wild West a little bit.
It is.
And you just try these things out. You do some R&D. You try a few different blends. We'll try maybe trying to develop a new line. We'll take, if we have an idea of what we want to try to achieve as an end use part, we'll just try different percentage blends, and we'll try different grades of PLA until we sort of find one that works. And we've been lucky to have the resources to be able to do that over the years and come up with some what we really think are some really unique materials, like and some of these were done also with Algix 3D before they stepped out of the 3D print game, and they just kind of handed over some of their materials to us. But that brings us to the algae line, Alga. So Algix removes nuisance algae from the waste stream, and they go around the world and sort of like find these algae blooms and these environments, like in China and Florida and elsewhere, where they've got these massive algae blooms and that are destroying wildlife in these waterways.
So is nuisance algae, is that just any algae that shouldn't be where it is?
Yeah, that's the blanket term to use, and we'll stick with that because I don't want to get into specifics and be wrong. So I'll defer to them. So,
okay.
But they remove this algae from the waste stream. We compound it with a special breed of PLA, and that brings us to alga, which has all the colors that are in the alga line. And alga has been out of stock for a while. It's been part of the sourcing and compounding issues this year. It's been a problem here. But we're actually just finishing a production run on it now. We'll have a first batch of it back in here probably in 2 weeks, along with Dura and Omni, a couple of the other materials that we haven't had in a little bit. But the colors for this line are really cool. It's a really sort of earthy color palette. The natural algae color is awesome.
We have that as our thumbnail.
Yeah.
All those
that's
chameleons.
right. That's right. And now this is standard PLA colors that normally would be a lot brighter and more vibrant. But algae content creates a really, really sort of cool earthy color palette.
We got actually an interesting question from Call Me Swall, which I think it'd be good to get your input on too, Buzz. He's asking, he just found out about our channel and the product, and he says he's curious, or she actually, I should say, if we think that FDMs are currently good enough to be used for manufacturing, not just for prototyping. And I think we can give our perspective from the automation side, but also materials is a huge part of that, and producing finished goods that'll be strong enough to go out to market.
I agree. There are a lot of materials out there with a lot of different characteristics that can be printed on FDM with a really, really low barrier to entry monetarily. If you can't invest in a Stratus J750, and most of us can't, FDM is going to be the way to go for starting out small, scaling up quickly. But yeah, I'll let you guys roll with the Quinley, because that is really what's going to convert something from a prototyping machine to manufacturing.
Yeah, and I think if you haven't already seen our Discord, I would definitely recommend anyone who's watching to go in there and talk with the people who are actually using it. But we have now plenty of customers who are using the Quinley system to do manufacturing of end-use parts. So these are products that are actually being sold and are visible. They're not just sub-assemblies that get hidden, which is also a really good use for FDM. But we have lots of examples of people using it for end-use parts, aesthetically critical parts, and FDM, we think is one of the only ways to do it correctly at scale. You've been able to achieve scale with things like SLA and like laser sintering or powder bed type machines, but they do have a bit of a critical limitation, which is the process for it is really complicated in that with FDM, your cost of equipment is really low. Your flexibility in design is really, really high. And part of that is, or the reason for that is that with the same FDM machine, you have an abundance of material choices, and all of these materials will behave differently. You might find a certain set of materials works really well for your printer, or a certain set of materials really fits the aesthetic you're going for. And where I was going with this is with SLA and binder jetting and that kind of stuff, the only way to really scale it is it's not very feasible to have many of those machines, because you have to scale up a labor force to operate that many machines. And while the materials in SLA and binder jetting and SLS are like really broad and really good and have a very wide range of applications, you do hit like an equipment and labor limit where you will just, in order to be able to achieve millions of parts per year, you have to hire a ridiculous amount of people with a ridiculous amount of specialized knowledge and skill. So one of the biggest projected issues in the 3D printing industry is actually the lack of labor availability, like skilled labor availability. You have to go through a lot more training to effectively use those large pieces of equipment, so much so that the reason you only see them being used in medical and aerospace is because they can afford to buy the $2.5 million machine, set up an entire room specifically for that machine, hire 10 people, have a technician on contract to make sure that that machine is maintained. And when you are paying six figures for a machine, you can buy like a big ass machine that can print thousands of parts. And that's what you'll see whenever those systems are used in production. You'll either see one of two things. You'll see with SLA, it will be like a factory of SLA printers, usually in a country where the cost of labor is very low, and you have a manufacturing plant there and just a ton of people running the printers all the time. On the flip side, you'll see for more local production, you'll see really big machines that take 4 or 5 days to actually finish the print, but they'll print 1,000 things at once. And in both cases, it's very difficult to scale. You can scale overseas, but that's just like, well, why wouldn't you injection mold at that point?
Right.
And you're only looking at geometry constraints. Like you might want to 3D printing might be your only option, but it's still centralized production overseas. You're setting up supply chains. It's very environmentally unfriendly, and it's kind of the more traditional route of manufacturing. And the flip side is you're spending $1 million a year on a team that is operating this 6 or 7 figure machine that sits in your lab on location, and you're like a giant company that can actually afford that. And that's kind of the aerospace example where you see people like Boeing actually using those as end-use parts, but it's so inaccessible. And again, because it's so expensive, you only ever see it used for parts that can't be injection molded. So it's like these, I think they call them low run, high value parts.
Yeah.
Yeah.
They consolidate
they do
a bunch of things into one part.
there was
Yeah.
a really interesting study that 3D Hubs, or just Hubs now, they put out where I think it was, I want to get this number correct. I think by volume it was 91% of parts were polymer prints with FDM on their platform. And and 3D Hubs is positioned as like a manufacturing platform, so it's a pretty good indicator of what most 3D printed parts look like. So it's FDM is already being used for production. It's just not very heavily advertised. And out of those, I think it was 91%. I can find the study in a sec, but out of those, it was something like 70% of the value of all the parts sold through their platform were also FDM parts. So like it's not, I don't think that we're looking at a question of if it can be used for final parts. I think it's more of a question of like how do we scale this now?
Yeah, and you know what? You bring up something you touched on reminded me really of just last year, um, when COVID first hit, PPE shortage and 3D printing really came to the rescue. A lot of maker spaces and hobbyists across the board just started printing PPE like crazy, and it was amazing. And it was true sort of distributed manufacturing on a level in 3D print that we've never seen. And it was really just, I mean, it's a great thing to be a part of. We were really happy to be able to, supply filament for that. But it definitely highlighted one of the problems with distributed manufacturing, and that is quality control.
Mm-hmm.
Because you have, someone printing on an Ultimaker or a Raise 3D versus, on an Ender or a Combrook, some, lower end machine, and maybe you've got the hobbyist versus the STEM expert doing the printing. You're going to get a wide range of quality variance throughout this massive distributed manufacturing realm. But and it's an easy, it's just kind of an easy switch to now look at something like the Quinley that eliminates so much of the human capacity for error here, where you've got something that's going to, once you get that part sort of optimized for 3D print, and it's going to print consistently every time. So if you can imagine this, look, I think we touched on this one of the other, when we talked a few days ago, that, we just went through COVID, at least on the PPE shortage, but we're still going through COVID. We're going through supply chain issues. One thing I've learned over the past year is that this whole global supply chain is really sensitive to change. Small changes can have big impacts, whether it's a hurricane taking out a compounding plant, a ship getting stuck in the Suez Canal, etc. We're going through COVID now and variants, and who knows what the next, global crisis is going to look like. Is it going to be climate driven, virus driven, supply chain driven? Who knows? But to have something in the field that can take a $200 Ender machine and convert it into a professional manufacturing station that can turn out quality parts consistently and quickly, uh, who knows how much of an impact that could have the next time we run into whatever the next giant crisis is. So
Yeah,
I really, I love this platform for a lot of reasons. We're really excited to be distributing here for you guys in the U.S. I've got a ton of schools and customers that are already interested, and I'm just trying to get the word out to them now. And I can't wait for to get more and more people adopting this platform to see how it changes their print labs, their maker spaces, and how they teach. I think that's going to be really exciting. It eliminates some variables that sometimes you want to teach, but it also shows really what the power of 3D print can be with a low end machine.
yeah. Well, just going off on one of your points there, just with the automation and with a bunch of people on very similar setups, if the point in time comes where we're running low as a society on like a certain 3D printable part, we can actually supply G code to people and say, hey, this works really well. It's very optimized. We've worked on it for a while.
Right.
You can print like 24/7 with this on your Quinley, and this is going to help your local community fill up on whatever part that it's missing out on.
Eric actually did this.
Yeah.
We spoke about it with him on a stream previously, but he had done an experiment. It was like an emergency manufacturing test, and he had students at a whole bunch of different sites with 3D printers, and the way they had structured it, which I thought was very, very smart, was they only trained the students how to calibrate the printer correctly. The students have no idea about 3D modeling or slicing or any of that. And once they started the tests, the students got the training. I think it was like an hour or two. They calibrated the machine, and then they distributed a piece of G code that had been tested and optimized by someone who was very proficient at slicing. And they were able to, that was that success rate we were talking about earlier, where except for that one outlier, by distributing G code centrally, they were able to get a 90% success rate on all of these parts with these operators who actually had no idea like anything about 3D modeling or slicing for a 3D printer. And because it's not necessary.
That's really powerful. That's really powerful.
And the fact that now, and we can't, I don't know how much we can say about it, but we have customers where they are buying Quinleys to set up at remote locations and then do the same, basically the same model that Eric tested with operators, except now completely headless, where you have Quinleys set up at your customer locations and you have one central lab, I guess a design lab. And once a part has been proven to work on the design lab, they're just going to dispatch the file to all the other locations. And the operators there don't have to be very skilled at all. In fact, with his first test, I know the client that was doing this, he just showed them how to level the printer. And that was it. And then sent files to them remotely and was printing on their system and printed overnight.
Yeah, well, I just thought of something here. Like, what if you had a 3D printer in every McDonald's, and every time a new Happy Meal toy comes out, you just say, "Hey, new toy, send it over," and then McDonald's just prints their own Happy Meal toys. Or like IKEA, for example, for like a more professional.
It would be nice because I know IKEA has they have vending machines that give you spare parts.
Yeah.
They should just have something where you order I want this this whatever wall decoration with this pattern. Maybe it has my name engraved, and you order online, and then you go to the store and pick it up 3 hours later. And
yeah, that could be a thing. IKEA. If you're
imagine
watching.
how much better because their whole thing is deconstructing everything and just having a big warehouse. Imagine if all they needed was a warehouse of printers and filament, and they could make thousands of different products.
Yeah.
We have an IKEA across the street from our office.
Yeah, this is why I talk about IKEA.
Yeah, I was actually there earlier today. Inspiring. I did pull up that study in case you were interested. You'll see it on the stream in a second, but it had the numbers that 3D hubs published. Let me just switch to that really quickly. So for 2020, total quantity of parts that was printed in PLA, ABS, PET-G, so that's definitely FDM, was 66%. They also have a number for nylon, TPU, ASA, PEI. TPU and ASA are almost definitely FDM as well. Nylon can be maybe SLS, but if we take it as most of these are FDM, somewhere between 66 and 91% of all parts printed on their platform last year were on FDM machines. And this is 3D Hubs is presented as a like a manufacturing and prototyping solution. They will do high volumes, as you know, expressed by number of parts here. And what's interesting too that we're seeing is the floor, the value of parts, um, adds up to, what is that? That's 72% of all parts. So like it's inherently less expensive than resins, and just the more we scale FDM, I think the lower these numbers are actually. Well, it
Mhm.
depends. It depends how they calculate this. If it's average value of parts or total value of parts. But it's just demonstrating like, okay, 91% of parts are already being produced with FDM most likely, and it's inherently less expensive than resins.
Yeah.
So it's pretty,
Like FDM is going to be here for quite a while, and it might never go away as one of
I
the
think it will
cheapest and
be,
most effective ways to
yeah,
get parts printed.
I think it will always be the lowest cost just because it's the most simple system, and you can, it's very easy to modify and scale,
Yeah.
and just a
Yeah,
barrier to entry
I
is low.
agree. It's going to be a long time before there's that real sort of logarithmic jump in FDM technology or SLA where it becomes that sort of easy home adoption. I mean, look, there's lots of LCD printers out there that are really, really inexpensive, but there's lots of issues with using resins. They are really expensive, and you have to post process clean. You can have toxicity issues or odors, etc. Not that I'm dissing it. I mean, I love the quality and prints that come off of that, those types of platforms. But I agree. I mean, I think sort of the material side, there's going to be a lot of growth over the next few years. I think in the expansion breadth of available materials. Certainly, we hope to be a good part of that with some of the green materials we're looking to put out, continue to produce. But I'm excited to see what comes next. I mean, it is a very, even though it's been around for a while, it's still a nascent space. Every time it kind of levels up, there's some kind of weird shift that happens and things change. I mean, look at, 3D systems and MakerBot back in 2014, 15 were, sort of king of the hill. And, then both independently, things changed and they got, 3D systems got out of the FDM space altogether. MakerBot went through some struggles with their own, and it really opened up the space for a lot of other manufacturers to jump in and sort of fill that void. It's almost like there's a mass extinction, and all of a sudden, these massive gaps in the phyla, and then they start filling in relatively quickly as people start coming into these niches. And I feel like it's we've gone through that a few times in this space, so you got to be prepared in this spot to definitely change course on a time. I know we have quite a few times already. Um, I feel like things have maybe leveled up a little bit, but then COVID happens, and all our 2020 plans went completely out the window.
Yeah.
And to completely change the way we did things, and it's who knows what's coming next. It's definitely adapting for sure.
Yeah, it's definitely, it's going to be interesting. The other thing that I, you might be interested in, that I've been looking at a lot, is actually seeing how the market projections line up with like reality, in terms of numbers. We know how 3D printers are being used, how much workers are required to run them, and it turns out like unless something like automation is implemented on a wide scale, there's no way that any of the projections right now for 3D printing are going to be met, because you're simply selling too many printers for the amount of people that can run them in the world.
Hmm. Someone should figure
Yeah,
out a way to automate
you're
them.
100% right. Yeah, I mean, look,
Yeah,
in our
interesting.
experience, we've sold printers to schools, to STEM educators who have never 3D printed before, and they've had, a really hard time getting up to speed. And then there's the parent that's buying it for their kid in junior high, and there's all kinds of inherent issues there. And the problem is, I think we look at 3D printers. Some of these printers look like it's going to be like an iPad or something. It's going to be really
Yeah.
intuitive and understand all your hopes and dreams. And the reality is very different, where in a lot of ways they're sort of similar to the old sort of Radio Shack computers from the, late 70s, like the TRS-80 or something,
Hmm.
where there's, it's a lot more involved with doing 3D printing. It's not the Star Trek replicator, right? So yeah, you're 100% right, because it can be really frustrating for people when they get a machine, especially when the barrier to entry is so low, when you can get a printer for $200. uh, you're destined to run into some issues, right?
Yeah.
So yeah, to really get that adoption rate higher, there has to be something to help eliminate a lot of the variables that can cause failed prints, jams, and everything else that goes along with new users in 3D print. So yeah, your point is well taken and right.
Yeah, it's gonna be interesting to see, like, because you actually do kind of see it, except for COVID. COVID was a really big year for printer sales, but you do kind of see the projections keep getting shifted out. And when you look at like the labor constrained projections, so I think we'll be posting this somewhere soon, or an article. But when I looked at like I took I assumed like a really generous growth rate of 3D print operators too. Like I think it was 18% growth year over year, which is more than double what the mech engineer growth rate for the US is, for reference. Um, and in 10 years, you're like five, 5 or 6 times short the amount of people you would need to run the printers that they're projected to sell by 2030. So like in 2030, there's expected to be just over 100 million FDM machines out there, and you'd need a workforce of 4.5 million people with current technology to operate the 100 million printers. And right now, it's estimated that there are probably 500,000 people that are skilled enough to operate 3D printers. So labor hasn't been a constraint yet. But when you look at surveys of companies and why they aren't adopting 3D printing or why they aren't using it more widely, the top two issues are always cost and skills availability. And so we're finally starting to see, at least according to the calculations I was doing, we're starting to see this year, next year, we're going to see labor really starting to constrain 3D printer sales. Either that, there's like a couple outcomes that are possible. Either labor is going to constrain and the market is just going to miss what's been projected, or they're going to be able to sell those 3D printers, but the productivity of them is going to be extremely low. And then the alternative is there's going to be some kind of automation technology that lets fewer people run more machines, which is the outcome that we're aiming for. Or 3D printing is just going to be, I think it was like it's going to be so inexpensive. There's some like other nonsensical way that you could make it the numbers fit, but it just didn't make sense. I think either there has to be automation on a wide scale, or 3D printing is never going to get into manufacturing, and it's never going to sell as many machines as are projected to sell, because there's simply not enough people to use them. They have to get a whole lot easier to use.
That's definitely an interesting perspective that I had not ever considered. And certainly, um, you know, this has not been the past year and a half has not been the best time for making plans,
No.
for sure. Every time we make one, we have to change it. That's okay. I guess it's sort of part of the fun, even though it's been a stressful couple of years with everything going on. Your point is really good food for thought, because as much as we love 3D print, etc. Like I don't 3D print myself anymore.
Yeah,
Like I
exactly.
used to when we first got into this. I don't have the time for one, and I wish I hadn't sort of fallen out of it, because I feel way behind the curve right now. I outsource everything to people I know that have thousands of hours on their belt, and they say, hey, can you help me? I'm like, let's test out this material, let's print this part,
Yeah.
and I just kind of let it go. But And for me, it's almost like, okay, what's my next printer going to be? Because I want to get back in and I want to just kind of get a, get a good printer home to play with. And, and even me in my position, I'm like, oh, geez, what am I going to get next? And I really don't
Right.
know. And I'm actually kind of eyeing like, oh, I think the Ender and the Quinley might be a great way to go for me because it eliminates some of the variables that are just destined to cause me trouble.
I think a lot of people can relate to that. I know Steven and I absolutely do, where
Yeah.
as we got more busy, it's almost like a sense of dread starting a big project on a 3D printer because you know that there are going to be nights where you're setting your alarm at 2:30 a.m.
Mhm.
to go and start the next print. But then when I started using Quinley like 5 years ago when I first started working on it, but once I got over that solution, like that was my pain was constantly having to monitor the machine. But now that I can just send files to it and not have to even look at the printer or go downstairs to to the system and fiddle around with the LCD and watch the first layer and stuff, um, I find myself using my 3D printer way more frequently. And I mean, before I let Steven tell his anecdote, like a lot of the customers we speak to too, it's been the same effect. Some people say, "Oh, I love using my printer now," or I'm using it more than I ever would have. It was just sitting and collecting dust until I installed the system on it because it becomes so easy to use and so convenient to use. Um, and then, in fact, you see people are getting second and third 3D printers when they previously didn't have enough time to even run a single machine. And
Yeah.
and yeah, it's kind of it's a bit magical. It's pretty cool to see like it is proof right there of how 3D printing is actually really accessible and really easy to scale as soon as you get rid of the intense operator requirements.
Yeah. Well,
Yeah,
having
I mean,
3D
what a
printing as
great
your job.
example of how, you're someone who's an expert in 3D print and you get frustrated with it or to buy it. It's almost like stop doing, you were like working out all the time and you stopped for a little bit and you're like just so like depressed about the idea of trying to get
Yeah,
your cardio back up.
exactly.
Like, oh my God, no, thank you, right?
Yeah.
It's just better to just stay on the couch, I think, tonight. But yeah, I don't know. That's a great point. Sorry, you were gonna say.
Yeah, no, I was just gonna say, like, with 3D printing as your job, sometimes you don't want to go back home and just do more 3D printing.
Yeah,
Um,
you get sick of it.
yeah, like at some point. But then, so getting a Quinley was nice, just so I can go home. I don't have to actually do all the 3D printing stuff. I can do my design stuff and just, hit print, get my part in the morning. I don't like leveling my bed. I don't like doing all the stuff anymore because I do it at work.
Yeah.
But yeah, just takes all the annoyance out of getting stuff printed.
It's actually funny. One of our interns from the summer, Sanford, we had given him, so he had an Aquila, and we had given him an Ender 3 kit to test so that we could make it compatible with the Aquila printer. And like he was using it so often, and even just for the print bed, like he wasn't doing large runs of parts, but it was so easy to use with the automated system. It just you hit print on your computer and off it goes. And the funny thing is he had that same process where previously he hadn't even considered having any printers because he didn't have time. Then when he worked here, he got the Aquila, and since he's left, he's gone back over to Ontario. He's left the automated Aquila here in Vancouver, but he bought two more 3D printers over there and hasn't automated either of them. And he was saying in our Discord the other day how just awful it was to go back after having an automated system. And
Yeah.
it's it's hard to describe to people until they've actually tried it, until they've actually used the system and actually felt how much time they were actually losing to manually operating the printer. Um, it's it's hard to describe it, but once they've used it for a little bit, even done a run of 5 or 10 parts, like it immediately clicks and people are like, oh, this is the best thing ever.
Yeah, well, I mean, some people have this nice like routine. They're like, oh, I love the process of like scrubbing my bed with alcohol and applying a glue stick and then leveling the bed as it prints the first layer. It's so fun. It's nice. It's enjoyable. And I'm
Yeah,
like, I just
that's
hit
like
the button.
yeah. I prefer efficiency. Like I know guys that are, like prefer to use, MS DOS, right? Like way back. I mean, I'm dating myself big time, but you guys, I don't even
Yeah,
know you know what that is. But I mean, but they prefer to work at that format than just have, a Mac or whatever. So yeah, no, I get it. Like, yeah, I can't wait to put my adhesive on the bed and then clean that later. We're scraping part off. I mean, I think one of the first things I ever did in 3D print was stab myself with a little pound bag
Yeah,
that came to
happens. Yeah,
when I
it's
was
the
trying to get core
ritual.
material off of something.
Yeah, it's that you have to make the sacrifice to the print gods before anything will actually stick to your build plate. That's the and
Right,
yeah.
right.
I like when I was doing a lot of scraping, or I would like actually have like little cuts and stuff on my hands quite often.
yeah.
And people would like, oh, why do you got those cuts in your hand? It's like, oh, I 3D print. Like, isn't that supposed to be
Want to know
safe?
how I got these scars?
Yeah,
Yeah,
yeah.
yeah.
But
It's
it's
very
supposed to be
normal.
safe, but it's really easy to nick yourself
Yeah.
or even burn your finger trying
And
to touch a
you
hot end.
decalibrate your entire print bed whenever you put force on it like
That's
that.
true. This is why we have vapor.
Yes. Yeah.
'Cause every time I've seen people get like a hammer to their scraper because their
Oh my.
part's stuck, and then Mateo just cringes.
Yeah. Yeah, I've stabbed myself like
Well, you guys are lucky that you get to work with these all day. That's all I gotta say.
that.
It's nice.
Yeah.
It definitely is.
Yeah, it is. And it's cool to be able to prove out your own tech in order to produce it for other people.
Yeah,
Since all of our Quinley parts are printed on other Quinleys.
yeah. Well, that's the answer to what was it? We had a question recently about like, can you print end use parts? I'm like, yeah, we do.
Yeah, all of our parts are
They're pretty good. They work. Everyone who's gotten them has turned it into a Quinley. So
Yeah, and they're printing end use parts too. We're getting closer and closer to the singularity every day.
where the Quinleys start printing Quinleys, the Quinleys will eventually take over.
Yeah, that's too
Yeah,
far
as
in
long
the
as we're not
Oh yeah,
violating
yeah.
the laws of thermodynamics.
Sorry, could you say that again?
I said, as long as we're not violating the laws of thermodynamics.
Yes,
Yeah.
that's true. People will always be shoveling coal into the electrical plants to power the printers.
Yeah, but well, look, I'm definitely I could not be more excited to offer the Quinley here in the U.S. I can't wait to get our customers educated on what it is and what it does. And I know there's going to be a lot of questions about what platforms we'll be able to run it on. And I know we've got a lot of things in the works already, so I'm really excited to see what you guys are coming up with this.
Yeah, it's gonna be really. I'm looking forward to seeing how it goes and actually getting feedback from your guys how what platforms they would like to see it on. We've already got so many in development. We have Ultimaker going into beta next month. Um,
We've got CR10 coming.
CR10,
CR6 SE is another one that we're looking at. Sidewinder,
Prusa
Fuchsia
Bear.
Bear. Yep. What else?
Yeah, those are all popular. The list is it's a long
It's
list
an endless
Yeah.
of
list.
Oh yeah, Ender Max as well. That's another one that we're
Yeah, I have to
possibly gonna
figure
get.
out how to produce vapor beds that large
Yeah.
consistently.
Well, that's it. We're trying to keep the beds to like a few sizes because once we have to keep like 100 different sizes of vapor beds, that's going to be terrifying.
And we have to test every single one still because
Yeah.
we're still developing things, but every single one that gets shipped is tested. That we do like a
We print on it.
we print on it. We do a 20 by 20 single layer print and ensure that it sticks well and that it completely releases
Yeah.
before we ship it.
Because the last thing we want is someone having like this old bed stuck to their bed that doesn't do what it's supposed to do.
Yeah.
So this is why we test everything.
Yeah. Hopefully.
yeah, it's harder for us to test every spool of filament before it goes out. It doesn't work that way.
Yeah, you print with the entire spool first and then
Right. Here you
rewind it.
go.
There you go. Now the polymer
Yeah.
chains are like
Then you have
20.
to remelt it back into the
Yeah.
spool. Then you have to test it again to make sure that remelting it didn't change anything.
Luckily, plastic extrusion is a bit more established.
Yeah.
Yeah, well, I'm really looking forward to seeing the Quinley out in the field with our customers, and I'm really hoping there's going to be a lot of new adopters. I mean, there's a lot of paperweights out there. I don't know how many, I mean, 3D printer wise.
Mhm.
I don't know how many, Enders and whatever else is out there that will be able to, get people to maybe get back into the game because they've gotten frustrated for one reason or another. And I don't blame them. I mean, I've had some lemons myself in fields,
We've
but
all felt it, yeah.
right, yeah, yeah. So I really can't wait to see how this thing is received out there. I know it's going to be really positive. I've already got a ton of interest already. A few
Oh,
people have been
sweet.
able to get up to speed on it.
And yeah, if anyone watching this now or later is in the US, please visit 3D Print Life, their website. I'll just put it up on the stream here really quick.
See if you could find their listing for Quinley too.
Yeah, it's there. It's there. Give it
It's there under 3D printers, and unfortunately, something happened with our parts and accessories page overnight. Nothing got really, but it's under both actually. We tucked it in a couple of different places. But
There we
it's
go.
it's in 3D printers
Yeah, check it out.
as well.
It's on Amazon too, or will be very, very shortly.
It is on Amazon in the U.S. We're working on getting on Amazon Canada as well for your Canadian customers if they want to go through there. I mean, Amazon, say what you will. I mean, it's, there's a love hate with Amazon. I think for a lot of people, as a consumer, they're great, but there's a lot of businesses and schools that are required to buy through there. So
Mhm.
whenever possible, so it's a good place to have your stuff featured for sure.
And I mean, while you're at it, pick up some sustainable filaments. I like the top-rated products right next to there. Everything we talked about today, like
Right.
the the play fab. I think we'll have to pick some of this up because I'm very curious.
Sounds good, like good stuff.
Yeah,
Yeah, as we're getting stuff off the production line here in the next few weeks, every time we ramp a new material through, I'll get you guys some material to work with
thank you.
and get your feedback on.
Yeah, and we'll also be testing out the replay on some of these packaging inserts too. So
Yeah, so stay tuned.
Yeah,
we'll update.
yeah, I'm excited to
And
see how that works out. I think
yeah,
the key with I think some people may have some hesitancy with sustainable materials, but we all use PLA all the time. It's the sort of universal material for 3D printers.
Hmm.
And, a lot of the materials that we have on the green side are designed to be eco-friendly, like PLA, but have some material characteristics that allow you, if you have a printer that doesn't have a heated bed or an enclosure, and you can't print normally with things like PETG or ABS or nylon, well, there's some eco-friendly blends that'll mimic those materials and are still good for the environment and print at low temps as well. And I'm sure they're going to print great from the Quinley.
Absolutely. Yeah, I'm looking forward to experimenting with these. It's always fun finding, well, depends on maybe if you're a sadist, I'll say it's always fun finding new settings for new filaments, but a lot of the times it's worth it because of just how interesting the materials are and yeah, being able to find new applications for these really innovative materials. I think that'll be kind of a goal of ours, especially starting with this packaging, trying to make it more sustainable. The cool thing about this packaging too is it is the lowest cost of any packaging we could find. Even purchasing cardboard packaging, it was less expensive for us to print it in-house. And now if we have the option to make it greener, then and less expensive, that's going to be really exciting.
yeah.
Well, I'm excited to see how it turns out. Definitely.
All right, well, it's been a good 2 hour stream, Buzz. Thank you so much for joining us. I'm sure we'll have more discussions like this in the future, and I'm super excited to be working. I mean, everyone, I should say, everyone here at 3DQ is super excited to be working with you, and yeah, it's gonna be awesome. And thank you for coming on to the stream. Thanks for sharing your insight too from the filament supplier side, because I think that's a world that a lot of people don't really get a peek into.
Yeah.
Yeah, I think I take that for granted a little bit. Most people don't get sort of eyes on how things are made and where they're coming from.
Yeah.
So, but listen, it's been a blast. I really had a great time. My pleasure, definitely, and looking forward to working with you guys for a long time.
Yeah. Thanks for your insights.
All right.
You got
Well,
it. All right. Hey, have a great evening, guys.
thanks, Buzz.
Bye, Buzz. Have a good one.
All right. Bye bye.
And we'll go back here. Thanks everyone who's stuck around to the end of the stream. Make sure to subscribe to the YouTube channel if you want to hear more things like this. We've got plenty more interviews and discussions like this in the works. Next week we actually also have a special guest, so that's going to be very exciting. So stay tuned for that. Also, make sure to join our Discord because you can speak directly with the special guest.
Yeah, and us.
And us.
We'll be there.
All the 3DQ staff are in there. If you need support or if you want to learn more about automation for 3D printing, join us in the Discord. You can subscribe to this channel. We also post a lot of white papers on our website and information like that. Our Instagram as well. We'll link you to some of the more detailed articles that we write, and I think if you're interested at all in 3D printing and how it can be used for manufacturing, I'd definitely recommend taking a look at that. Jack says every week is a special guest.
Yeah.
Every week is a special week. And he wants us to drink water. We will drink water as soon as the stream is over.
Yeah, we don't have water with us. We're all dehydrated right now.
It's very dry here. Although we have a rain warning tomorrow.
Oh, cool.
Yeah.
Oh, it's actually really nice today. I was so glad it was like cold but sunny. Now we're getting rain.
Tomorrow it won't be. Anyway, on that note, we'll see you all next week. Thanks for joining us.
Bye.